Well, this question, let's take a look at it. It says, do men score lower on average compared to women on their statistics finals? So this is a very relevant question to us, huh? You men and women taking statistics, planning to take the final in a few weeks. So do men score lower than women? Or no. Yeah. Do men score lower than women? The my answer to that question on average over my many years, yeah, the men do. The women usually do better in all my classes. Um, but I don't mean to discourage you men with that. I hope some of men do great. But yeah, in general, the men do a little bit lower. Let's see if this data bears that out. The final exam scores on 13 randomly selected male students and 11 randomly selected female students are shown below. So these are some actual. So one of the men got 84 on the final, another one got 79, 78, 87, da, 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 da. These are the whatever they said, 13, yeah, 13 men. And these are like 11 randomly selected women, what they got in the final, these different scores. Okay. Does it look like the men do lower than the women? Well, we'll do a hypothesis test to see. First thing is we have to, it says for this study we should use which test. When you click that, there's 8 different tests. How do you know which one? Well, notice first off, we're talking about, well, we're talking about averages. I mean, it never says the word, never says the word average. Oh, yeah, no, yeah, it does. There it is. Do men score lower on average? Yeah. So we're talking about averages, right? And we have 2 groups, and we certainly have data. That's certainly data. So, okay, now the question is that we want to answer, is it dependent? So if you look at the notes, let me show you the notes up here. So here's the notes. So we know it's not up here. It's not proportions, right? It's not percentages. It's 2 independent means or 2 dependent samples with data. Which one is it? Because you might think, oh, it's right here. It's data. Well, this has data here too, right? Watch out. There's 2 places with data. So the real difference is it independent or dependent? What does that mean? Well, right here, look, 2 groups are not matched in pairs. They are independent versus data is matched in pairs, actor, actress, male, female, before, after, with, without. So you want to ask yourself, let's go back to the question. Is this dependent or independent? Ask yourself, are those 2 connected in any way? And then are these 2 and these 2 and these 2 and these 2 and these 2, are they? No. This is independent. They're not. You think, well, what would connected be? Connected would be if this was like a husband and his wife, right? Husband and wives are connected. They affect each other. So we're talking, what is this? A final exam score. So if this was husbands and wives, we would think, husbands that do better are probably gonna be married to wives that do better, and they just tend to go together. They'd be connected. They'd be dependent. So what dependent? So ours is independent, meaning they're not connected. Independent means not connected. So if 2 things are independent, they're not connected to each other. Like, what do we call members of the family? Your dependents, right? I mean, if you're a husband or wife, father or mother, your children are your dependents. They depend upon you. They're connected to you. Well, in this case, these numbers, the top and the bottom, the men and the women, they're just random men and random women. They're not connected in any way. They're not husbands and wives or actors and actresses or brothers and sisters. We could have, brothers and sisters. That would be dependent. If they said, we did this study, we picked, 13 sibling groups, brothers and sisters, and tried to see how do brothers do better than sisters or vice versa on the final. That would be a dependent because they're connected, right? Brothers that do better are probably, probably the whole family probably does better, right? But these are independent. They're not connected. This person, this man that got an 84 is in no way connected to this woman that got an 84. They just happen to both be listed first. Could have been, they just could have been over here random. Doesn't matter. No connection. It's not. So again, one more time, if you look back at the notes, dependent means they're matched in pairs, like actor, actress, male, female, before, after, with, without, brother, sister. You may say it's like male, female. Well, it's men and women, yeah, but they're not connected. They're not brother, sister, husband, wife. So it's not so you can't just look for words. You got to really go for meaning. right? You can say it's just 13 randomly selected males, 11 randomly selected females. They're not connected in any way. So this is independent. So watch out, that's tricky. So we're down here. So we're in two independent means. Two groups are not matched in pairs. They're independent. On online calculator, two independent samples with data, or with says we're doing with data because we have a data list. Two independent samples with data. So we come down here. Oh, and first thing is we're going to choose the t-test. How do we know that? Two independent means, right? Again, there's independent, and these are certainly averages, means. So that's why we select that. And then we're going to go to the online calculator. Let me get rid of these right here. We're going to go to the online calculator right here, which is two independent samples with data. So two independent samples with data. Because we have data, don't we? What do we do with that? Well, what does it say to do? It says there's the null hypothesis and the alternative, right? So this HO is mu1 equals mu2, and H1 is mu1 and mu2 with greater, less, or not equal. Let's go do that. So we're going to have mu1 equals mu2 always, right? HO is always equals. And this is mu1, mu2. Now, what are we going to put? Is it going to be greater, less, or not equal? So I'm getting that out of the notes. It says it right there. HO is always equal. H1 is greater, less, or not equal. So which one is it? What does it say? We look for keywords like bigger, smaller, higher, lower, things like that. What does it say? Um, lower. Do men score lower? So lower is less. Because that first group is men and the second group is women. How do I know? Well, that's just what order they're at the table, right? This is the first group, men. This is the second group, women. And so the first group is men, second group is women, is saying, do men score lower? So men here, men less than women. That's the question. So the two attorneys are arguing. This attorney, HO, is saying men and women are equal. And this attorney is saying, no, the men are lower than the women. Which one's true? Which one does the data support? So we're going to take this data now and we're going to paste it in. That's what it tells us right up here. You got to choose the radio button, matching H1, and then paste in the data. So I'm gonna choose the radio button, which is less, right there, from H1. It's always from H1. And then I'm gonna paste in that data. So that is the deal. So then you just copy and paste that data and put commas between them on that. So yeah, I wonder if I can do that. Let me see if I can find it. Find the actual question to do the copy and paste of the data. Yeah, there it is. Where is it? Yeah, okay. So I'm going to grab the min data first, like that. I'm going to copy it. I think I just copied it. Come over here to the calculator. Oh, I'm on the wrong calculator. Let me go back to it. So we're doing two independent means with data. So two independent samples with data. Number 17. Two independent with data. 17. Two independent with data. 17. Come up here, data one. Hold it down and paste it. There it is. There's the first data. And then I got to go data two. You got to put commas between those, but let's first go get data list two, or maybe I'll just do it right now. So put commas. Where's the comma? This is a little tedious here, but you do have to stick commas between these guys. You don't have to you don't have to fix the spacing. Just put commas between them. Just copy paste commas between them. Good. All right, now data list two. Let's go there. Data list two, which is this one down here. And copy. Paste. There it is. And put our commas between these guys. So we're putting in the actual test scores, the averages on the final, stats final, that these two, these are made up, but this is what you could do in this real life example. Okay, we get to choose a radio button. Now, which radio button are we going to choose over here? Remember it, we're going to choose less, right? Wasn't it less? Let me double check. Yeah, it's less. Right there, less. All right, back to it, choose less, and that's it, calculate. Calculate. Boom, there we go. Oh, we hear about the T and the P. There it is. So just put those numbers in with commas. T and the P. The P is 0.0112. Let's see, let's go back. 2. Yep, got it. Okay, so there's the T value, negative 2.455, and the P value, 0.0112. We got them. Okay, so now we're ready to draw a conclusion. How do we do that? You remember, I'm sure it's always p-value compared to the alpha level to finish up a hypothesis test of any kind. So what is our p-value right there? 0.0112. What's our alpha level? And right there, alpha 05. 0.05. All right, which one of those is bigger? Well, the 05, remember, is bigger than 01, 05. 05 is bigger. So 05 gets the wide side. The bigger number goes on the wide side. So yeah, okay. And so then what's our saying to draw the conclusion? If the P is low, then the HO, the null, must go, meaning go away. So if the P is low, the null must go. Now, is our p-value low? Yeah, our p-value is less. Our p-value is less. So our p-value indeed is low. So if the p is low, the null must go away, which means reject the null. So you're getting rid of the null, so that means you're keeping the other one. You must be keeping H1, right? So I'm coming to that conclusion. Is that making sense there? So again, the saying that we always use to help us draw our conclusion: if the P is low, the null must go. If the P is low, the null must go. Our p-value is low, it's less, so the null must go away. Reject the null. If you're rejecting the null, you got to keep the other one, keep H1. Now, a lot of students ask me, Mr. I don't know how to do these last ones, the strong and the less than, greater than. How do you do that? Well, that's all just from HO or H1. In our case, H1. I'm just going to go back to H1 and do what it says. One thing you want to put in here, HO is always, without exception, HO is always weak evidence. And H1 is always strong evidence every time, because that's like a court of law. HO comes first, just like in a court of law. What do you do first? You first assume that the person is innocent. And if the evidence is weak, you stick with that innocent assumption, you let them go. That's weak evidence. That's HO. But if evidence is strong, then you go with H1, you convict. Okay. So what are we doing in our case? Again, back to it. We're keeping H1. So let's just let that guide us. Keep H1, go back, go, okay, then H1, you're our baby. We're keeping you. Keeping H1. What is and then just do exactly what H1 says. What does H1 say? Strong evidence. Strong evidence. And mu1 lower than mu2. That is lower. We believe there's strong evidence. Mu1's lower than mu2. So that's our conclusion, as we see right here. Strong evidence, and the men are lower than the women. So this data, these numbers, these statistics, final exam scores are strong evidence that the men score lower than the women. That is our conclusion. And there we go.